Good afternoon. My name is Ms. Francina Finley Kurt, a first-year teacher candidate at the Cyril Potter College of Education. I am pursuing an associate degree in early childhood education. This is my final assessment for Physical and Biological Science, SCI 122. I have selected project number 4, which deals mainly with force and to a lesser extent elasticity.
I have selected project 4, and here are the questions that follows. Plan and conduct an experiment to compare the elasticity of the following materials: socks, rubber band, elastic, and jersey material. B. Define the term force. C. Explain how your experiment can be used to deliver the concept of force to the students of your class. D. Suggest why materials do not return to their original state after extensive force is applied to them for a period of time. Question A. Plan and conduct an experiment to compare the elasticity of the following materials: socks, rubber band, elastic, and jersey material. Title of experiment: a comparison of the elasticity of socks, rubber band, elastic, and jersey material. Objective: to determine which of the 4 items is more elastic by pulling each material 50 times, and so by applying force. Materials used are a socks, a rubber band, an elastic, a jersey, measuring tape to measure. Methodology. Number 1. Place some measuring tape on a table in a permanent position. Number 2. Measure the length of each of the 4 materials when they are in a state of rest and document their measurement before pulling. Number 3. Pull and apply force to each material and relax it 50 times and then re-measure, documenting to. Number 4. The item with the greater elasticity would be the one deviates less from its original length after force is applied to it for the specified reps period of time. According to Encyclopedia Britannica, elasticity is the ability of a deformed material body to return to its original shape and size when the forces causing the deformation are removed. The table of results shows the original measurement for the rubber band was 3 inches and it increased to 3.5 inches after being pulled. Force was applied 50 times, hence it stretched half of an inch. Elastic, on the other hand, was 6 7/8 inches and it increased to 7 5/8 inches after being pulled. Force was applied 50 times, hence it stretched 3/4 of an inch. Further, the sock was 6 3/8 inches and it increased to 8 1/8 inches after being pulled. Force was applied 50 times, hence it stretched 1 3/4 inches. And the jersey material was 10 inches and it increased to 12 1/4 inches after being pulled.
force was applied 50 times, hence it stretched to 2¼ inches. It can therefore be deduced the material the return the closest to the original measurement after force was applied, pulled 50 times, is the most elastic and vice versa. Based on the finding of this experiment, it was found that the rubber band is the most elastic of the 4 materials examined, only deviated by ½ inch. This was followed by the elastic, which deviated only 3/4 inch, then the sock, which deviated 1 3/4 inches, and the least elastic was the jersey material, which deviated by 2¼ inches.
According to the Encyclopedia Britannica, force in mechanics is any action that tends to maintain or alter the motion
of a body or to desert it. Force can also be described intuitively as a push or a pull. The concept of force is commonly explained in terms of Isaac Newton's 3 laws of motion. According to Newton's first principle, a body that is at rest or moving at a uniform rate in a straight line will remain in that state until some force is applied to it. The second law says that when an external force acts on a body, it produces an acceleration change in velocity of the body in the direction of the force. The magnitude of the acceleration is directly proportional to the magnitude of the external force and inversely proportional to the quantity of matter in the body. Newton's third law states that when one exerts a force on other body, the second body exerts an equal force on the first body. This principle of action and reaction explains why a force tends to deform a body. Example, change its shape whether or not it causes the body to move. The deformation of a body can usually be neglected when investigating its motion. In the International System of Units, SI, the unit of force is the Newton's N, which is defined as kilogram meter per second squared. This definition means that 1 Newton is the force required to accelerate a 1 kilogram mass by 1 meter per second squared. Now, question C. Explain how your experiment can be used to deliver the concept of force to the students of your class. The elasticity of a rubber band can be used to deliver the concept of force to students in my classroom through the following steps. Number 1. I will introduce the concept of force by explaining to students that force is a push or pull that can cause an object to move. Number 2. I will demonstrate the elasticity of a rubber band by stretching a rubber band in front of the students and show them how it can be pulled and stretched. I will also explain to them that the rubber band is elastic, which means it can return to its original shape after being stretched. Number 3. I will have students experiment with material rubber band by giving each student a rubber band and have them stretch it different amounts. Ask them to observe how the various materials feels when it is stretched and how they return to their original shape when they are released. Number 4. I will then discuss the relationship between force and elasticity by explaining to students that the more force that is applied to the materials, the more they will stretch. Conversely, the less force that is applied to a rubber band, the less it will stretch. However, some materials are more elastic than others. Number 5. I will have students apply their knowledge of force and elasticity to all other materials, elastic sock and jersey material. Have the students experiment with these materials and observe how they respond to different amounts of force. Number 6. I will then conclude the lesson by reviewing the concept of force. Ask students to define force and explain how it can affect objects. Have them share their observation from the experiment and discuss how they can apply their knowledge of force to other situations. Question D. Suggest why materials do not result to their original state after extensive force is applied to them for a period of time. When a material is stretched as force is applied, it undergoes deformation. The ability of a material to return to its original shape after being deformed depends on the material's elastic properties.
This is described by Hooke's law,
which states that the force needed to extend or compress a spring by some distance is proportional to that distance. In other words, materials will return to their original shape after the force is removed, as long as the deformation is within the elastic limit of the material. However, if the force applied exceeds the elastic limit, also known as the yield strength of the material will undergo plastic deformation. Plastic deformation is a permanent deformation that remains even after the force is removed. This is because the atomic structure of the material is rearranged in a way that cannot be easily reversed. The elastic limit and the ability to undergo plastic deformation vary widely among different materials. For example, rubber has a high degree of elasticity and can be stretched a lot before it undergoes plastic deformation. On the other hand, materials like glass have a very low degree of elasticity and will break before they can be significantly stretched.